Góðan daginn allir og good morning everybody, and welcome to this webinar, this meeting that we will have here today with Pius Floris from Jarðrækt. Today's topic is agriculture or Jarðrækt, how your crop can help you to make your soil healthier. Next slide, please, Pius. Our objectives of these meetings is to educate on sustainable growing methods for all kinds of growers and to help supply with fertilizers for organic farmers and regular farmers. Today's topic is Jarðrækt, agriculture, as I mentioned. After a 20-minute presentation, we will take questions. And you can already put them into the chat box of Zoom in Icelandic or English. And then we will present several products of ours. And then at the end, we will talk about our next educational meetings that will happen in the new year. So Pius, take it over. Go ahead.
Thank you, Jota. Thank you very much. And thanks again for the invitation. And thank you all present for listening. Just technical, I don't see a chat box. Maybe that is something that needs to be added, but anyway, let's start with something pretty contrary to what most people say. And I would say only plant roots can make soil. We cannot make soil. We can mix all kinds of ingredients. Oh, Jota, maybe you can mute everybody. And only plant roots can make soil, basically. And if you cannot mute everybody, then you can ask everybody to mute.
I've muted all, yeah.
Plant roots make soil, and these trees on a cliff in the mountains, they don't grow there by themselves, not just like that. We will talk very slightly about the soil food web first, because what I want you to see, and I don't see, can you follow my arrow on screen?
Yes, we can.
Okay, great, thank you. It starts with sunlight. From sunlight, we will have photosynthesis. That means that the energy from the sun goes through the green plants to the roots. And from there, this energy feeds all kinds of soil life. But it starts with the roots. The roots produce what we call exudates. And these exudates, sugars, complex sugars, and the roots themselves, they form organic matter. And the sugars and the organic matter, they feed all kinds of organisms. They, in what you call the second level, the decomposers, etc. They are, in their turn, consumed by the third level. And the third level is consumed by the fourth level. And the fourth level is consumed by the fifth level and higher level. So basically, all life on Earth and in Earth starts with soil, with the energy in the soil, and starts with the soil life, then ends up above ground, and we eat plants and meat, etc. So it's very relevant here to Patricia. Oh, thank you. It's very relevant to see that the soil food web plays a big role in life. So today's session is about how important plants are for building up the soil biology. I will show you how reciprocal. So reciprocal means two ways. The soil and the plant symbionts are. And we will also talk about what photosynthesis means for the soil quality. Imagine a bare soil, just cooled off lava. Your island is full of it. Just imagine bare lava. What happens first is that you will have some vegetation, mosses, lichen, and from early stage vegetation, it will start moving into forest. But you have to have the mosses first. Mosses, lichens, ferns, that's where it starts with. And these pioneers, they feed the bacteria and they leave carbon behind in the soil. And they leave the carbon and the bacterial mass for the next generation of plants, which will be, for instance, these plants growing along almost every road, and we call them weeds, but they are plants in a succession. They have their task, they put more sugars in the soil, because you can imagine that the photosynthesis of a moss, of a small moss, puts photosynthesis and exudates in the ground. But the bigger the plant is, the more sugars it will provide to the ground. So you will have the first primary roots in the ground, or in the, we don't call it soil yet, but it's ground or rock if you wish. Many of these root hairs, they provide the sugars in the soil, and they take some of the soluble nutrients, and these nutrients are solubilized by bacteria. These are the minerals that are solubilized by bacteria. So the successive plants, they will start their interaction with a virgin soil, and they do that by means of exudates. And you do have to realize that plants deliver 1/3, 30% of the total amount of photosynthesis straight to the soil. And they really do that for a reason, because they need the cooperation of the soil organisms. It will affect the plants, and you will have a more porosity soil. The roots exudates, they modify the water retention, hydraulic conductivity, etc. So it's a real interaction. It's what you call a synergy and mutualistic. So rock, lava, sand, they need to contain the microbes and fungi that live on organic matter, which is sugars and dead and old roots. And that's how it all starts. And from that point on, succession plants are able to grow and provide more and more complex sugars to the ground, become soil slowly. So this all happens in a zone around the finest roots, and we call that the rhizosphere. In previous sessions, I've been talking about the rhizosphere. If you feel like it, you can go back in these presentations. Jorte published them on Facebook, and I'm always open for questions if somebody or you don't understand clearly or somebody doesn't understand. So this is where it all starts. The rock, lava, sand, they need to contain the microbes and fungi that live on organic matter. And plants are able to grow there. They provide sugars to the organisms, and the whole place is called the rhizosphere, like I said. And the root exudates, they consist of sugars that feed the organisms in the rhizosphere. And this makes the plant dependent on these organisms. Plants do depend on the soil organisms. Somebody has a microphone open and that disturbs. The dependency is mutual. The soil depends on the plants for its development, and the plant depends on the soil for its development. So plants and soil, they need each other. Like I said, plant exudates are really relevant. They produce the glucose, which is transported to the roots. But if you look at internet, many of these simple pictures, they talk about the glucose on the right lower side. And it's pulled outside, but actually it's going into the roots, into the soil. So chlorophyll is based, carbon dioxide is exhausted, that goes in, oxygen goes out, and glucose doesn't go out, it goes to the roots. So the internet is also pretty confusing in these pictures. Plant exudates are really relevant for a healthy plant. And in these plant exudates, you will have so many metabolites that help the soil life. And the soil life produces so many metabolites that, and we talk about hundreds of metabolites. We don't even are on the beginning of discovering the role of all these plant metabolites, because all of us are educated in the mineral way. Plants need minerals. Yes, they do, but they do need a lot more minerals than we think they need. And we have learned that the minerals that we give to plants are absorbed, and therefore you have a healthy plant. That's not even close to the truth. Plants need a lot more than the 17 minerals, and I've talked about that before in my very first webinar for you. So these exudates, they actually feed the rhizobia, the bacteria around the roots. They produce the secondary metabolites. They produce volatile organic compounds that help to defend the plant against pathogens. They produce organic acids, of course. And they feed the mycorrhiza. That means they do that in two ways. And maybe it's too complex, but ectomycorrhizae are fed, and that's for pine trees and birches, etc. Many tree species on Iceland are ectomycorrhizal. And ectomycorrhizae grows on the sugars that leave the plant roots on the outside. The endomycorrhizae, they grow into the plant cells and they obtain the sugars straight from the roots. It's only a slight difference, but we'll get there. So all in all, and it's in the bottom corner here, it reduces the dependence on fertilizers. Yes, because the soil can deliver a lot of everything that a plant will need. So back to the rocks. After all the succession of all different plant stages and growth stages, now the first trees can go and they can develop and they actually crack the rocks. They will literally break stones. And the fungi will help them with that. They make the first small cracks and they will fill with water and the fungi will die off and the water will freeze and it will crack the rocks, etc. So you always talk about the combination of mechanical and biological weathering. And now again, we go back to this picture. All growing energy depends on sunlight. By photosynthesis, the quality of the root exudates are determined. So the better your leaves, the healthier you plant, the more sugars it can produce. If you feed your plants with simple minerals like synthetic nitrogen and potassium and kalium, well, it's the same, not. If you feed your plants with phosphates and kalium and nitrogen, that's not enough, really. And plants suffer from that, and it will certainly attract diseases, because then plants are forced to produce simple sugars. And simple sugars attract pathogens. It's written by Chabousseau already in 1985, and there's a lot more literature. So the rhizosphere depends, the quality of the rhizosphere depends on the quality of the exudates. And that's where we go to the biology, the rhizosphere biology. And the rhizosphere biology is very complex. And every time you dig a hole, you plow the land, you add new soil to the ground, to a forest, you have cultural measurements in forests or in cities. It doesn't really matter. Everywhere you mix the ground, you destroy the biology. We know that. And if you plant shrubs, or if you seed grasses, or if you plant trees or replant trees, you will find the same problems, basically. The grasses will germinate, but then they will deteriorate until you apply the right biology in that disturbed land. Because every time you dig in land, the soil is disturbed, no matter what you do. No matter whether you're a professional or a hobbyist, a shovel in the ground means disturbed soil. But how else can you plant a plant? How would you plant a tree without disturbing the soil? And that's always a dilemma. And that's why trees take so long to recover after planting. That's why garden plants, they take a year to adapt to the changed biology. And it's the science and the science behind our products that adds the biology to the disturbed soils. It's not more complex than this. So we came to the development of products that are helpful if you have naked roots, young plants, young hedge plants, forestry plants. You can easily dip them in a mix, a cocktail of bacteria and fungi that are truly rhizosphere biology. So what you do actually is you make in a disturbed soil, or may I say a wounded soil, and that tree that came from the nursery is wounded as well because the fine roots are gone. So you put a wounded plant in a wounded soil. Why not add the biology to make it right from day one? And that's what we have the micro dip for. It's an existing product already more than 20 years old. Injectable. You can, if you discover that your plants or your trees or your shrubs are not growing well after planting, maybe because you planted them last year and they don't grow, you might consider to inject the bacteria and the fungi in the soil next to the plants and between the roots, and that avoids digging, avoids new disturbing. But on the other hand, you cannot add the rhizosphere biology on top of the soil. because that's not where it maintains the life. It needs to be where the roots are. So, and like I said last session also, for forestry, for planting trees, but also for shrubs, for annual plants, it really works to put the biology there where you made the hole. And we are still very proud already for, I don't know how many years, on the BioVin product. Jotto can tell everything about it, but that BioVin is suitable for planting almost everything. It does not contain mycorrhizal fungi. That's really the difference. That's why we talk, concerning the BioVin, we talk about soil biology. But the rhizosphere biology also need to contain mycorrhizal fungi. So we have a combination of products. Tree Saver Transplant contains the mycorrhizae, both ecto and endomycorrhizae. But also you can add the BioVin, mix it in the planting hole. Whether it's an annual plant or a big tree, it doesn't matter. Mix some of the BioVin in the planting hole and you will actually help the plant to grow. It's a short presentation this time. By helping plants to establish well, you will help them basically forever. And since it's the last webinar for this year, I want to thank you all for attending this webinar. I hope it was, this one and the previous ones were educational and informative as well. And I hope to see you for the next webinars in January. And after that, I really, really, really hope that COVID is over and that we will be able to travel again so I can meet you live on Iceland, not only because I love to be on Iceland, but I also like the discussion and to talk and to educate. For now, thank you very much. A Merry Christmas and a good start of the new year. Stay healthy. Thank you very much.
Thank you, Pius. Do we have time for one or two questions if there are
Yes,
somebody?
absolutely.
Yeah. If there are some questions, ef það eru einhverjar spurningar, þá getið þið annarkvort bara tekið unmutað ykkur eða afþakka eins og þannig að nota á Íslandi og spurt. Við erum búin að tala svolítið tré. We've been talking a little bit about tree, but we can talk about broader growing examples or something else you like.
Well, nobody has a microphone on. And are there chats available?
Hvar fæst efnið? Where do you buy those products? Our website is vege.is. And we are working with Plant Health Cure. It's phc.eu. You can all find it on you can find it on Facebook and also on our website. And you can have a chat with me about those materials and how to order them. There are several products to choose from, but there are organic plant food and BioVin, and some of the others are really good. So you can use them by themselves or together, depending on what you're doing. And some of the products you can also buy in Blómaval. BioVin you can buy in Blómaval, and it's called Jarðvegsvinur, and OPF granular is called plantnærir. Það er áburðurinn. You can buy this in small dosages from 2 kilos up to 1,000 kilos. It's 2 kilos, 7 kilos, and the BioWin was 25 kilos and 600 kilos, if I remember correctly. So most of the products
20
are
kilos actually.
suitable for big farmers and also for small growers in their greenhouses or in their gardens. So you supply this in different product sizes.
I wish there were more questions.
Yeah, do you see the chat box? It's on.
Yes.
Yeah.
Oh,
there's a big one.
from Love. No.
Yeah. Can you see this question?
Okay. I'm running into difficulties with heirloom barleys in the field college. I'm running an experiment on micro treatment at home. Click pills export. Oh, okay, I don't know if everybody can read these. All right. It's great that you are working now with mycorrhizal treatments, Glückpilze and pre-infected Ugromycoccus. Okay, first, Glückpilze, they're spores. The pre-infected coccus as a media, I really doubt if the mycorrhizal fungi will survive on that medium. I'm really not sure. You want to overcome the phosphorus problem, which is very interesting with, of course, with mycorrhizae, but also very much depending on bacteria. And now you look at Bacillus thuringiensis, I would never do that. I would not advise to use single species products because they will not help. You should always use a mix of bacteria. We people cannot do things on our own. Bacteria cannot do things on their own either. So despite all the information there is, use mixes. And really, frankly, if you talk with Jurter, you might want to mix the Glückpilze mycorrhizal spores together with Biovin to start with, and you will already have a better use of phosphates. But it really depends on how you use your phosphates. I hope, and it's better to apply microbes that raise soil temperature. Yes, they actually always do, but they don't expect miracles. Bacteria start acting with like 10 degrees Celsius soil temperature. Berglind had a question. I cannot read that.
Yes, the question is, my potatoes have black warts or some. Do you know what? She also tried to change her ground, the soil, but it didn't change. So what causes black warts on potatoes, and what can we do about them?
Let me check. I'm almost answering this question. If I find Google Translate. Icelandic. Dutch. Black rods. Your potatoes have black rods. Would it help? It's a fungus. I really don't know how the fertilization goes. You had a complete change of soil. but nothing changed really. Well, maybe you plowed the soil. Maybe there was something else going on. But I'm sure, and we have this in practice, and the science shows you can actually, if you have enough good fungi, there's no space for the bad fungi. And it's a too simple explanation, but if you increase your potato health, then you will have healthier potatoes. So I hope this was enough answer, but adding biology will always improve.
Mm-hmm.
I hope Berglind is now satisfied with this answer.
Yeah, hope so. Some more questions?
Yes, there's a few more.
It's comments about this potato problem. Yeah, all of them. Yeah.
They call it itch. Okay.
Okay, I think
Berglind had, what is that? Yes, Berglind's right, but it's a fungus, and it has to do with the soil biology.
mm-hmm. Very good. So I think we should continue, bring this to an end. Next meeting will be on January 5th, was it? Will be about carbon binding. Then on January 19th will be on foliar feeding, your favorite. And then we will have trends in environmental legislation. So we are looking forward to that. Thank you all. Thank you, Pius, for this interesting presentation, and Merry Christmas to all of you.
Thank you very much.
Yeah.
Thank you. Namaste.
Bye-bye.
Merry Christmas, and see you next year. Stay healthy.
Yeah. Bye.
Bye-bye.